Welcome to Network 360 channel. In this video, we are configuring Aruba controller OS 8 version OS 8 in high availability without mobility master. We are using two controllers, one master and another one is standby. Use case for this video is controller. Only one controller is using the production. He want to add the redundancy, but he don't want to go with the mobility master. So we are configuring basic configuration of Aruba redundancy using VRRP and IPSEC. Master redundancy also we are using. We will configure already one controller is configured and running in production. So second controller we will configure. We will add to the master controller as a standby, and we will sync all the configuration. We will use L2 redundancy. VRRP is the main one. We will configure the VRRP, then L2 redundancy and master redundancy. Drawback of this type of configuration, because we are not using mobility master. So whenever the AP is making the AP having the PAPI tunnel, so it's only one tunnel will be live to the virtual IP of VRRP. If one controller is down, then AP should create new tunnel to the virtual IP, same virtual IP, but backend the controller will change. So now in normal cases, 3 to 4 ping losses we can see. Benefit, what is the benefit? We don't want to buy the or separate license for the and the master license, we can use it in the standby also, and configuration we can sync the configuration from the master to local. The structure of this configuration, we are using two virtual controllers, version 8.6 running on the Hyper-V server, and one access point in my lab. One access point, it's 105 AP 105 one quantity. Currently one controller and one access point is working perfectly, and I can connect. It is working, and I can connect to the SSID. Everything working as expected. Master controller license is activated, SSID's configuration is done. The main steps are we will configure L2 redundancy, VRRP, master redundancy, and database synchronization. This is the three steps. First, on the controller level, we will configure VRRP. On the controller level, we will configure the master redundancy. Then the folder level, we will activate the database synchronization, and we will give the database synchronization delay also we will give. So as I said, the first one controller and one AP is working perfectly. So we have to start from the second controller. Second controller is factory defaulted settings. We will do the basic configuration. Once basic configuration is done, we will verify both the controllers GUI and SSH. Next step, we will do the VRRP. Then we will check the VRRP configuration, VRRP master and backup. We will verify the master and backup. If VRRP synced, everything is okay, L2 connectivity, everything is okay, then we will do the master redundancy using IPSEC. IPSEC version 2 is by default it's using. Once we configure the master redundancy on both controller, we will see the IPSEC SA is built or everything is okay. Everything, the tunnel is successfully created the tunnel. We will check the logs also. Then we will enable the database synchronization on the folder level. So once we enable the database synchronization, which is the VRRP master, So on the production one, we will make a VRRP priority make high. Normal priority is 100. We will make 150 or 200. So the master will be the primary, and the configuration from the master will sync to the standby box. This is the summary. This is the diagram, my lab setup diagram. I am using VLAN 800 and I have two controllers, master controller and standby controller. Currently standby controller is not configured, it's a factory default. And master controller IP is 8.251. I will use the 8.252 for the standby controller, and VRRP IP I will use 8.10. AP, it's Aruba AP 105, and we can see how it is taking, because once the VRRP configured, then the IPSEC is after that we will configure IPSEC, then the database synchronization, everything is done. Then what we will do, the production AP group LMS IP we will change to VRRP IP. Then after that we will reboot the AP, then we can see it will connect to the VRRP IP. And the last step, we will reboot master controller, then the AP will automatically switch to standby controller. Second controller, we will do the initial configuration, then we will check both the GUI and SSH of both controllers. One controller, as I said, it is already in the production, and one client is connected. For the VRRP, because we are using the virtual devices, so we have to remove the IPSEC offloading and MAC spoofing. We have to enable MAC spoofing, and we have to remove protected network settings in the Hyper-V network adapter settings. So let's start. We'll go to our Hyper-V server. We will start the full setup. VLAN ID as per our diagram 800. Its access port, yes, we will use 192.168.8.252. Subnet mask gateway 192.168.8.1. 192.168.1.200. No, I don't want to. India. This time we will change later. It's a rebooting. After reboot, we will resume. Controller is rebooted. So first we will check communication to gateway. Okay, success. So later we will change the host name. We change the host name Aruba Standby. Now I said before we have to do some changes in the network. I already did it because we have to remove the VMQ and enable IPSEC offloading. In the advanced feature, you have to enable MAC address spoofing and remove the protected network. Because why we need to change these settings? we are using VRRP. If we enable this setting, sometimes we will face issues. So that settings already done. Now we will check on the GUI both the controllers, Aruba Master and Standby. So now the basic configuration is done for the second controller. The first controller, as I said, it's in the production. So you can see 8.251. Its host name is Aruba, and it's only one controller, Aruba. Yep. So this is 8.251. This is the one we were adding, 8.252. So default settings, we don't have any configuration, only the IP and gateway. We can see that license, nothing is there. So it's a default configuration. Now we are going to configure the redundancy. Default controller, we don't have any SSID. Go to the Aruba, we'll see our SSID, production controller. Here we can see lab. So as per our discussion on the steps, first we have to configure the redundancy in L2 mode. Giving ID as 100, master, password, virtual IP. Priority by default 100, and I will make 150 because I want to make this controller as a primary one and sync configuration from this controller. I want to enable the preemption, because if the preemption why we are enabling, if the controller is down and the standby controller will be as a primary controller, once the controller is coming back, then all the role will be changed. That's the delay preemption, and we enable the preemption also. This is for admin status and VLAN 800. Other field is not required, tracking is not required. Submit. So VRRP configured on the controller level. On the second box, VRRP 100, authentication password should be same as what you give in the master. Default priority, no need the preemption. VLAN 800 I already created. When we are doing the basic setup, that time we give the VLAN 800. That's why it's coming here. Switch IP as a VLAN 800. Submit. Now we will go back to SSH and do the verification. We log in both controllers in PuTTY SSH. We will see the VRRP. Show VRRP and router ID 100. It's master. Virtual IP is 8.100. This is the MAC and VLAN for 800. Preemption is 60. On the standby controller, okay, it's a backup. So seems to be VRRP it's made and master as per our configuration. Priority 150 is master, 100 is backup. We'll see status. VRRP status on the controller. Admin status is up. We are master. It's sent, received, current time. So seems to be VRRP it's good. What about other controller? That also good. We'll see the logs. Last, we can see that the transition. Okay, VRRP status. You need to backup 8.10. This is the command execution 150 action 1. Everything seems to be normal. Received 8.10 from VRRP and state is changed. VRRP state you need to backup. First it will go to backup, then backup to master. So VRRP ID 100 transistor to backup to master. So same command we can execute in the standby device. This is the commands which we executed. Okay. It's showing shutdown state. Show VRRP. It's good. Both the MAC address is correct. We will try to ping. Okay. Okay, so VRRP is up and we are able to ping 8.10 virtual IP. So first step is successfully configured VRRP. Second step, IPSEC IKE version 2. So first step is done. VRRP is up on the GUI. On both controllers is up. Now we have to, on the master controller, we will start master redundancy. Okay, we have to give the VRRP ID, same VRRP ID. Then peer IP address 192.168.8.252, then IPSEC key. Deploy on the second controller. We have to give the VRRP ID 68.251 peer IP. Submit, apply changes, done. Now we have to verify the IKE tunnel between these two controllers. So now we completed the VRRP. Now we are in the IKE to the IPSEC. It started. We configured. This is the verification. Show crypto ISACAMP status states. Then the phase 1 ISACAMP SA, phase 2 IPSEC SA. We can see the logs. If there is any error, we can see show log, error log. So we will go to the SSH and we will check it out. ISACAMP is up. What is the status? To verify the ISACAMP, show crypto ISACAMP. Okay. Switch IP is 8.251. That's correct. Standalone mode. We have to go in V2. Okay. It's initiator, responder. Okay. So it's initiated, and we can see that SA. Show crypto ISACAMP SA should be, we can see. So our controller is 251 and initiator is 252. The top one is for the AP. You can see RV2 CC responder version 2 IKE, then C, small c, RC signature, because this is for the, we are using CPSEC for the APs. That's why it's certificate based. So this is the one, controller to controller SA, IPSEC SA. 8.252, 8.252, RV2, small letter R, responder version 2 P, pre-shared key. It's up and running. You have to check the ISACAMP also. So phase 1, now we will see IPSEC SA. IPSEC SA also is built. Tunnel mode T2. This is UT2 because it's UDP. So we can see that our ISACAMP is up. We will see in the, we will check it in the second controller. Okay, because here we don't have AP. The master controller, there is AP, that's why you can see 2. Now it's a responder and it's up and running. One more thing we have to see. Show IP interface brief. We can see VRRP ID 8.10. On the first controller also, show IP interface brief 8.10. Okay. So first step is VRRP, second step is ISACAMP. Now third step is to enable the redundancy and sync the configuration. That we have to do it from the master controller. Yeah, master controller, folder level, redundancy. On the folder level, redundancy, not in the controller, in the folder level. So enable the database synchronization. Give 1 minute or 2 minutes. So in this period, the database from the VRRP master, it will sync to the standby. Now we enabled. We will check. This is the master controller. Show database synchronize. Okay, the synchronization succeed. Show database synchronize one more time. Wait. Okay, succeed. So we will check it in the second controller. Show database synchronize succeed. On the second controller, we should see the configurations. Now, we should not see. Okay, on the second controller, we can see the license. Yes, license is updated before because license is applied on the folder level on the master. All the configuration is done on the on the controller level. That's why configuration is not syncing. So now we have to go back and take the virtual IP. Okay, we got the access to the virtual IP. You can see Aruba. That means now virtual IP is binded to the priority high one, the master one. Admin. We should see two controllers over there. Now we are in the Aruba. If you go to that folder, now we have two controllers, Aruba Standby and Aruba. And Aruba Standby, if you are to configure something, configuration for the Standby control must be done at the mobility control group level. That means folder level you have to do, then only it will come to the both the controllers. This is the group level for testing. So whatever the configuration we made here, then it will affect over both controllers. We can add one VLAN for testing. Submit, pending changes, deploy changes. So we created VLAN 400 in the folder level, root level. We will see on both controllers we got it or not. 400. So configuration synced, and we are getting. If we did any configuration at the folder level on the both controllers, we are getting. Now configuration, everything is done. VRRP is configured perfectly. We have to verify now configuration, everything is done. We have to verify what is the switch status. On the controller master, we can see 8.251 is its master and its standby. This is both are in standalone, and we can see the update is successful. Firmware version and update status. This is the one, it's a standby controller. Update status is successful. Show AP database. We can see AP105 up. The last part is AP is pointing. Instead of physical IP, we have to point to the virtual IP. So currently it is managed by Aruba. So we have to go to the configuration, then AP group. I am using the default group for, then LMS IP 8.10. Submit, pending changes, deploy. we have to reboot the AP. Currently it is 8.251 switch IP. That means master. Okay, it is rebooting. After rebooting, we will check the status. AP is rebooted, but still it is attaching to Aruba because my in lab setup controller and AP in single VLAN, and Discovery is using the ADP, Aruba Discovery Protocol. That's why L2 broadcast it is coming. That's normal. If it is a production, normally it will be in the different VLAN using the DNS, Aruba Master, or DHCP service. That IP you have to change to the VRRP IP. This is the old setup. Thank you for watching. Please like and subscribe. Thank you. Bye bye.